Hi, Juan. How are you? Hi, everyone. How are you doing? Hello, everybody. Okay, so today we're going to do lab 6. Let me get my Rebel open. Good. So check out the lab. You can find that in Canvas. We're going to work on random today to simulate dice. Okay. We'll start in a few minutes, so just hang tight. Okay, so download the lab if you just join us, and then we are going to start in a few minutes. They're pretty easy program today. So we're going to use srand. So we have 1 more minute and then we'll start, okay? Okay, so we'll go ahead and get started. Let me go into screen share here. So right now we are going to do lab 6 in CIS7. So in this lab, we are going to simulate dice roll, and we are going to use srand. So now with the C++, we can generate random number using srand, and with srand, we are seeding the random function at a certain value. So we will determine whether it's truly random or it's not, right? So usually random number are calculated by taking the previous number or the seed. So it's seeding from the previous value and then do the operations for the following number. Okay, so keep in mind that it's going to seed based on the previous value. And in order to generate a random like number, srand is initialized with the runtime value. Okay, so that's important to make note of. And so this is why we want to include the header file run ctime. So to simulate the dice game or the 20 rolls in the dice, we are going to write a C++ program using srand. And so in the first part, it talks about srand, then it goes into rolling dice. So for our first program, we are going to simulate 20 rolls on a 6-sided die, which is a standard dice. And we are going to print the value for each of the roll. So now with the when we prototype the function ran, we wanted to use stdlib, and we would use the mod to mod 6 because there are 6 faces in your dice. So what we will do is we will use ran with the mod 6 because there are 6 faces. And that will give us the integers that's going to be from 0 to 5. And so that way we can scale the number so that way we can show it as an output. Then we would then shift the range of the numbers produced by adding 1 to the previous result. So that way these numbers can differ once one compiler to the other supposedly to be random. So what we're going to see is we are going to see a random like set of numbers that's generated from our dice roll. So in this program, you are simply using stdlib, and here it talks about how we need to use that file in order to bring in our rand, and we wanted to incorporate the mod with 6 in that we wanted to generate it for 6 face dice. Okay, so just to get through the program, so in the program you have the header file, you have input and output, everything is built into the main function. You are going to iterate, so we are going to loop 20 times to simulate 20 rolls. Okay, so for the for loop, you start with the first, which is going to be the first roll, and you're going to go up to the 20th roll, and you're going to increment. And every time what we're going to do is we are going to add the 1 plus rand, which is the function, with the mod 6. And 6 comes from the 6th face of your dice. So this will allow us to display the number that it generates for the roll. Okay, and because we're rolling 20 times, so for example, the first time we get a 2, the second time we get a 5 and a 4 and a 2 and a 6. And keep in mind that we're going to see based on the previous value. Now, now for this, the if statement, it says that if the index mod 5 is 0, then we're just going to see out. So if the counter is divisible by 5, then begin a new line. So this is just a way that we format the display in that we would have 5 per row and 5 output each of the row so that we can show that, okay? So it doesn't really have anything to do with the actual value that it's showing. This is just to display it in a specific manner. And then we have return 0 that would complete our entire program. So once you take a look at the program, then what you will do, looking at example 1, is you will enter that program, and you don't have to put in all the comments. You can include the comments so that way you know what's going on. And you want to run the program, okay? Then after you run the program, you look at the output, and then you want to take a screen capture, and you can include it in the document. So now, to make it look like it's real, it's randomized, right? We use the rand. Now, if it's truly random, if I run it again, I should get a different output, correct? Okay, so let's try it again. So after I run the program the first time, I'm going to run it again, and notice it's the same. And then run it again, same. Okay, so this looks like it's random, but it is not, right? We didn't incorporate the seed time to make it truly random. And we also, because it's seeding from the previous value, so that means that it's always going to give you the same output every single time as the program is written. Okay, so when you use random function like this, and if you don't incorporate the runtime with it, and if it's seeding from the previous value, it's not truly random, okay? But this program does simulate the 20 roles. So now if we look at the calculation side, for the first exercise, it asks you to calculate the probability of obtaining 1 using a 6-face dice in 20 roll. So if I need to get a 1, that's only 1 face, right? And there is 6 faces total. So that will be 1 out of 6 in 1 roll. And if I do 20 rolls, that will be, the probability of that will be 1 out of 6 in 20, and with the power of 20. So if we are doing 20 rolls, remember the product rule, right? We would take 1 6 and we multiply 1 6 and multiply 1 6 20 times. So that will give us 1 over 6 raised to the power of 20th. So that will give you the probability of obtaining a 1 in 20 rolls. Now, if we look at what we're excluding, right, the 2, the 3, the 4, the 5, and the 6, because we're only focusing on obtaining 1, in question 1B, it asks us to calculate the probability of obtaining the number other than 1 using a 6-face dice in 20 rolls. So that means that we would take 1 minus 1 over 6, which gives us 5 6. And we simulate that for 20 rolls. So it's 5 6 to the power of 20th. That will be that will be other number that's not 1. Okay, that's the probability for other number that's not 1 in 20 rolls. Okay, any question with exercise 1? A and B. So as you look at the calculation, right, the program doesn't really give us a probability. It's just going to give us the output, and we use random number or random function to generate the number for 20 roles. And we mentioned that it's not really truly random in that when we run it again, we continue to have the same value over and over again, right? As the program is written. So when we do the random function mod 6, because it's 6 phase, and we would do a +1 to make it unique from the last value, then what we have is we have the same set of values for 20 roles every time we rerun the program. And the if function, the if down here with the I mod 5, all that does is it's just format 5 values for each role that we output. Okay. So when we did the calculation, we showed that in order to, if we look at the probability of getting a 1 in 20 rolls out for the 6 face dice, that will be 1/6 raised it to the 20th. And then when we calculate the probability for obtaining number other than 1 in the 20 rolls, that will be 5, 6, because we take 1 minus 1, 6. That gives us 5, 6, and then raise it to the 20th for the 20 rolls. Okay. Now we want to just scale out the number. So all you have to do is put down the frequency of how certain number shows up. Okay. I see a chat question. Yeah, you can keep your answer in fraction. That's okay. That will be easier for you. You don't have to use the calculator. So keep it in fraction, it's fine. And you don't have to multiply out the exponent. That's fine. Just you can keep it like that. That's okay. Okay. So now what we want to do is we want to look at how the numbers scale. Okay. How frequent is a certain number showing up? Okay. So if I go back to my program, let's say I start with the number 6. Okay. And I wanted to look at this so I can make an observation on how is it giving you a certain numbers in a certain frequency, right? So to really get in depth, you probably have to see how they write the random function, how that's generating the value. So if I'm looking at the scale of the number, for the number 6, it shows up 2 times, right, in the 20 roles. Okay. So I just make a note of that. I have 2 of the number 6, and then I would put down for the scale for all the other ones. So let's look at the number 3. Okay, how often does 3 appear? I have 1, 3 here and 1, 3 here, so I have 2. Okay, and then let's look at the next number. Let's look at a number 5. And you can keep it in order, so let's do that. Okay, so if we look at the number 5, the number 5 appears 1, 2, 3, and 4 times. Okay. Four times for number 5. Then we can look at the number 4. the number 4 appears 2 times, so we scale it at, so 2 for number 4. And earlier we mentioned that the number 3 scales at 2, so the number 3 appears 2 times. Okay. And then for the number 2, I have 1, 2, 3, 4, 5, 6. So 2 has the highest frequency. 6 times for number 2. And then I can look at number 1. And so for number 1, 1 scales at 1, 2, and 3. So it appears 3 times in the 20 rolls. 3 times for number 1. Okay. So based on this, right, based on our output, our result from our program, we can see that 2 has the highest frequency. It appears the most. Okay. And the second highest will be number 5. Okay. And then the rest, except for one appears 3 times, the rest are just 2 times. So you can make a note of how many times each number scales. Now, based on the frequency, we can say what is the probability, right? So, for example, out of the 20 roll, the number 2, it appears 6 times. So six times in the 20 roll. So what the question asks you is how many times does it appear in the 20 roll? So for 2, that appears 6 out of 20. For 1, right, it appears 3 out of 20, and so on. Okay. So question D basically asks you for the ratio of the frequency in the 20 roll. And then you can put like for number 3, I have it appear 2 times, so 2 out of 20. So we can conclude that a program like this doesn't really give us the true random aspect, right? So if you write a program like this to simulate the dice, it looks like it was random, but it is not. And so we have to take a look at the aspect of how frequent certain phases show up based on the algorithm that we implement. Okay. So 2 has the highest frequency based on our observation from the result of our program. 2 has the highest. So that will be the answer for E. And the second highest will be number 5, right? Then I want you to rerun the program and see if you get the same result or different. And you need to put down the explanation on why or should the result be the same or different. And we talked about that, right? Okay, any questions so far? So this shows you how to look at ways to simulate dice game, right? And in this case, not the best solution, even though it's using random function. So the question is asked, so what do we have to use to make it truly random again? So we will see. If we later on we will have a program that's going to use srand and we would incorporate time. So it's the if you use the runtime to seed, it's gonna make it more like a randomized number. Okay. So in the future, when you write your programs and you want to randomize values, let's say that you want to randomize card distribution, or if you use a built-in function like this, you have to consider how that function is seeding. What value does it start with? Okay, and in this case, it starts with the previous value, and the previous value is static, it doesn't change. So that means that your outcome will not change if you don't incorporate the time factor. Okay. Yeah, no problem. I know that in 17A or CIS5, right, you have a chapter and it goes over random function, how to use random function. And there's a section in almost all texts, it talks about what makes it truly random and what makes it looks like it's random. Okay. So this kind of review a little bit on how you would look at that. But since we talked about probability, okay, you can use it to make an observation. Okay. All right. So once you put down your reason for F, and you should just put the explanation on why the result's the same or not. Okay. For G, what I want you to do is let's change up the program. Okay. You can replace the mod 6 with mod 8. Let's say that if the dice is 8 face, okay, and we can rerun the program. So I'm going to go ahead and do that here. And let's say we don't use a standard dice. We use an 8-face dice. And we can still generate it for 20 rolls. And we're still going to output, right, 5 per. Okay. So now what you did is when you change it to 8, right, you increase that scope. Instead of going from 1 through 6, we will now go from 1 through 8 for the face. Okay, so you still have 20 rolls, but now it also includes the 7 and the 8. It adds those two into the mix. Okay, so you can simply change that value. And then take a screen capture. And I want you to make a note of the frequency of the program output. So we can take a look at, let's say, number 8. That appears 2 times, right? Then for number 7, that also appears 2 times. For number 6, it appears 1 time. And for 4, now if what you can do is if you wanted to test this, test it on REPL and test it on Visual Studio and see if you get the same. Because earlier in the notes, it talks about how that one value is added. Okay, it says here that we then shift the range of number produced by adding 1 to our previous result. The output of the number differs from one compiler to the other as it is supposed to be random. Okay, so when you do the comparison, you can also look at how one compiler handled it compared to another compiler, right? Because it's supposed to give you a different value. So after we change our value to 8, when we run the program, take the screen capture, and then we wanted to note the frequency. And then out of that, what you can do is you can note which one has the highest. So for number 5, it has 1, 2, 3. I have 3, 5 on mine. And then for 4, I have 4, 4. Okay. 1, 2, 3. Yeah, 4, number 4. And then I only have 1, 6. For 3, I have 1, 2, 3, 4, 3. And then for 2, I have 2, number 2. And I only have for number 1, 1, 1. So it looks like 4 and 3 are tied, where we have 4, 3, and 4 of the number 4 in the 20 rows as output. So once you put down the frequency of the scale, then you can note which number has the most or the highest frequency. Is it different than what you've seen in D? I'm sorry, in C? So notice that in earlier when we have 6 phases, 3 and 4 is the same, but it was not the highest, right? Okay. And then could be a coincidence, but we would have 3 and 4 is the same as they would have, but they at this time have the highest. And you can tweak it, you can play with it. So let's say if I change this to mod 9, right, rerun it, and then I can look at the frequency and so on. So you can test it by looking at how it's randomizing from a smaller range compared to a larger range of phase or values. Okay. So in a program like this, right, we use a loop to just quickly generate the output. And we don't have to do anything else. The rest is just for the format. Okay. So once you know the number that has the highest frequency, then let's say if I wanted to make it 40 rows instead of 20, keeping the 8. So now if we keep the 8 and then if we increase this, if we loop it more, right? Okay. So now you just have more output because now you're looping it 40 times instead of 20. Okay. And then I want you to make note of which number has the highest frequency. So when we look at this, you can quickly kind of look through. 8 has 4 and 5. So you can count up the number that has the most frequency and you can make note of it. Okay. So what we did was we were just testing, right, with how it uses the random function with a higher value. And then now if we loop it more, is it going to generate the same pattern or a different pattern? Okay. So once you change it to 40, rerun the program, put down the number that appears the most. Okay, while you're working on that, let me go and open number 2. Okay. Okay, any question on 1? That one's pretty easy. Okay. All right, thanks for letting me know. Okay, so let's go on to number 2. So exercise 2 or example 2 is another program that's going to simulate dice roll. So it tells you here that to show the numbers that occur approximately with equal likelihood, let's simulate 6,000 rolls of the die with the program. So that way we would say that each of the number from 1 through 6 should appear approximately 1,000 times. Okay. So let's take a look at the program, how it's created. So here's the program. So what we have is we have in the main, and again, we're using rand. Okay, so you would include that. So you would have frequency 1, that's going to count the first one. So instead of using the loop like last time, so we would have a frequency 1 that's going to store how frequent that would be. So we initialize it for all 6 faces to store the frequency of the number. Then we have a variable called roll. That will be your roll counter. That's going to be value from 1 to 6,000. Then we have a face that would represent the value between 1 to 6. Okay. So what we can do is we would then loop it. Okay, so we have a for loop. We start at 1 and we're going to go up to 1,000. And just like the previous one, we are going to do a 1 plus rand mod 6. And in this one, it uses switch keys. Okay, so to kind of simulate the first roll, the second roll, the third, the fourth, the fifth, and the sixth. Okay, and we want to increment for the frequency as we initialized them previously. Then the last part is just to show, so we wanted to show how frequent each of the phase shows up. So let's run this program. So we see that the phase 1, it counts it for us, right? And we're using rand. So it shows us that phase 1 shows up 173 times, phase 2, 150, phase 3, 179, phase 4, 181, phase 5, 155, and phase 6, 162. So the one that has the highest frequency is phase 4. And phase 3 is pretty close to that. Okay, and in this case, we have it loop 4,000. Okay. So now after you put the program into your IDE, okay, you can rerun your program. And every single time I get the same result as expected, what I talked about in the last one, right? So again, when we're using the rand function to generate random number like this, we don't have a true random set of numbers as output, right? Because if it is random, you would have different frequency output every single time. Okay. So when we check it, it appears the same. So that means that the values, the roll values are exactly the same every time. Therefore, we have the same set of frequency. Okay, so I want to run it a few times, then answer the question, does it provide different result each time? Okay. So based on our observation, we can put down the phase that has the highest frequency. And we mentioned that phase 4. Okay. So for the phase 4, when I generated this, I have 181. Okay. Let me look at your thing real quick. Sorry, I apologize. I think I changed this to 1,000. So let me rerun that. Okay, so that's different. So I had edited from the last semester and I forgot to change it back. So when we put it at 6,000 here, we see that phase 3 has the highest. Okay. So for 6,000 roll, that will be phase 3 has the highest frequency. And I have 1030 out of 6,000. And the probability of having the phase 3, that will be 1/6 to the exponent of 6,000. Okay. The one that has the least is going to be which one? This one, right? Actually, phase 1, 980. Phase 1 has the least. So for the next question, it asks you, which one has the lowest frequency? And that will be phase 1. And for phase 1, I have 980 out of 6,000 rule. It shows up 980 times. And the probability of phase 1 in a 6 to obtain a phase 1 in a 6,000 rule is 1/6, and raise it to the exponent of 6,000. So if you compare this probability with the frequency probability, right? Does the program represent what the math is showing us? Okay. So when we look at this, we would see the ratio, right? And this is another ratio. So mathematically, we would know that for the phase 1 to show up in the 6,000 rule, this is the probability. But our program output is this, okay? 980 over 6,000. So that tells us how accurate is that program simulating the dice roll. Is it representing the math exactly, or is it not? Okay, so now what we're going to do after this is we are going to scale it down to 100 rolls. Okay, we're going to go from 6,000 to 100. Then we can just simply change this. Okay, and then we rerun the program. Okay. So in the 100 rolls, we see that 4 and 2 have 18, which is not the highest, and then phase 3 has the highest, which is 23. So for D, all you have to do is you have to edit the program and make it 100 rolls instead of 6,000. And you want to make a note of which phase has the highest frequency. So on mine, it shows 23 for phase 3. So the frequency for phase 3 is 23 out of 100. And its probability is 1/6, raise it to 100. Then if we look at the one that has the lowest frequency, going back here, the lowest frequency would be phase 5 and phase 6, which has 12 each. Okay, they have 12 each, and that's 12 out of 100. But the actual probability for phase 5 or phase 6 would be 1/6 raised to 100. Okay. Okay, any question? So for D, you just modify it to 100 rolls. So change that for your loop. Okay. Run the program, make note of the highest and lowest frequency, and show the probability of the outcome compared to the actual probability in the calculation. Then you're going to repeat the same thing, but for E, we're going to make it 1,000. Okay. So we would modify this. Oops, sorry. We would add the 0 in here, rerun it. So you saw earlier that we have 181 for phase 4 that has the highest in the frequency. And the lowest would be phase 2. So what this shows you is that even though, right, it looks like it would be a program that would solve to show, right, how frequent, right, the probability of certain phase to simulate the dice, but it doesn't really hit or correctly address the mathematical side. Okay. So here, this is why we wanted to do the calculation and see how that program out result represent that calculation. Okay. So if you build a program to solve a problem, you want it to be accurate solving that problem. So for E, we changed it to 1,000 roll. We note the one that has the highest frequency. We note the probability of that particular phase in 1,000 roll, the probability for that. We note the phase that has the lowest frequency and its probability in calculation. Okay, any question? And then for F, I want you to evaluate both exercises. Once you assess it, you can describe the similarities and difference in the result based on the use of RAND. What general observation can you draw about RAND in exercise 1 and 2? Because I see projects turning in, students use RAND all the time for C++, for, you know. So keep in mind how you use this function to, as, you know, part of your algorithm to solve a problem. So Sarah asked, do we divide the frequency to get 1/6? So if you're looking at the frequency, right, the frequency just shows how many times it appears in that many rolls. The 1/6 comes from one phase out of the 6 phases in the dice. right? You're only going to have one phase, that's number 1, okay? And the exponent is the number of rolls, because if you're looking at one time, that's going to be 1 6. 6,000 times, that's 1 6 times 1 6 times 1 6, because it's a consecutive set of choices in that 6,000. Okay, so yeah, you don't have to divide anything. You can leave it as a fraction like this, and this fraction just represent the ratio of the frequency in the 1,000 roll that phase appears. You're welcome. So if we put this, and I wanted to show you this, so let's look at, so let's say that if we take this one, right, you know that this is 23%, okay? But if we do 1/6, okay, so 1 divided by 6, and then if we raise it to 100, right? This is the decimal equivalent for this, okay? Compared to 0.23, so it's way off. Okay, so what the program is outputting is way off compared to the actual probability. Yep. Okay. So put down your observation for F. So the next time that you think about how you want to incorporate random in your program, when you write your program, you need to think about how it is either, is it a pseudo random or is it truly random? Okay. All right. So for the next part, we're going to work on srand. So for rand in exercise 1 and 2, rand generates pseudo-random numbers. Calling rand repeatedly produces a sequence of number that appears to be random. However, the sequence repeats itself each time the program is executed. So when you're looking at rand function, like what we talked about, right? It looks random, but it's not. And this can help you debug a program that uses rand function. Once the program has been thoroughly debugged, it can be conditioned to produce a different sequence of random numbers for each execution. This is called randomizing, and is that it can be done using a standard library function srand. So for srand, it takes an unsigned integer as a parameter. That means it takes a positive integer, and it's going to seed the rand function to produce different sequence of random number for each execution of the program. Okay. An important note with this is that in this one, on the example 3, we are going to include C time. Okay, that's going to be your runtime. And when you look at the program layout, it's very similar to the first one, right? Not too different, but the difference is that in this one, we are going to include the runtime. And also we're using srand. Since we incorporate C time here, we're going to pass it. Okay, so that way it would seed differently every single time. So that way it's going to generate different values every single time. In the first one, we don't have this component. We don't have the time component. So it seeds using the previous number, and that previous number is the same every single time it's run. So for this one, what we're going to do is we're going to incorporate the time component, which allows us to seed to generate the random number. Okay, so let's, while we transition to the next one, I used to use different program that's longer, and I thought to myself, I said my students are going to get so confused. So I edited over time, and I wanted to use simple programs so you really understand the concept. And you know, writing program like this is super easy, right? So let's take a look at the structure of the program. We have a main function, but again, like I said earlier, so you're going to include the cstd lib. Okay, that's where ran really is, right? And then your C time, okay, which allows you to use time here. So you have a main function. We have a variable for the counter, which is I. And in this one, we're going to use srand. Then we are going to have the time. And then here, it's just going to be null. We have a for loop, and we're just going to simulate 10 rows. Okay. We're still going to have 1 plus rand mod 6. So this stays the same as the last one. But because of this, it's going to generate this the random for different, it's going to seed differently. Okay, so it's going to use the time to seed that. So, and then when we output, we're going to still output 5 numbers per row. So we should have 2 rows of number. Okay. So here I have 6, 4, 5, 1, 4, 4, 4, 5, 3, 6 for my 10 rows. And I run it again. I get a different number. 1, 6, 2, 6, 6, 4, 2, 6, 3, 6. So Jose asked earlier, so how do I do a random number program? Well, you would use srand with rand. Okay. And in below the program, I put a note. srand time null causes the computer to read its clock to obtain the value for the seed automatically. Function time returns the number of seconds that have passed since midnight on January 1, 1970. This value is converted to an unsigned integer and used as the seed to random number for the random number generator. Function time takes null as the argument, and it is found in the header C time. Okay, so now you know what srand time null does in that program, because it's different as it would be generating using its seeding, right, based on the clock. Okay. So now we wanted to test the theory for srand, right? Based on the program that's written. So run the program. I want you to run it a few times and see if it's going to be different each time, right? It should be. So it looks random, right? So after you run it a few times, make note of it. Does it look the same or different? Then we would then calculate the probability of phase number 6 in the 10 roll. There's only 1 6 out of the 6 phases, and we're going to roll it 10 times. So 1 6 to the exponent of 10. Then I want you to again look at the frequency. You can pick the highest value, the highest frequency. And it's different every single time, of course, right? So now we just look at the last time that you roll, pick the highest frequency number, and then show me how that is out of the 10. Okay, so for example, here's mine. I have 4 ones, so 1 has the highest frequency, and that will be 4 out of 10 for what the output of that program would be. And then look at the lowest frequency and how that the ratio of that frequency would be in 10 roll. So if I look at this one, the lowest frequency would be 1, 2, 3, that will be number 5. I only have 1 time. So 1 out of 10. I guess that's pretty accurate, right? 1 out of 10, and I'm going to get a 5. But because of the pigeonhole theory, right, we are rolling above the 6 phases, so there will be numbers that's going to be repeating, of course. Okay, so after you note the highest, the lowest frequency, and its ratio out of the 10 rolls, then you can increase your roll to 20. We're going to scale it out now. We're going to scale it up. So I'm going to go ahead and change this to 20, and let's run it. Okay. So if I want to write a similar program for card games, right, etc., you have to take a look at your cardinality, okay, and your sample space. And then you want to seed it with the clock, so that way it will be random versus the other one is pseudo-random. So now after you modify this to 20, rerun the program, right? The output should be different because you have more now. Okay, you have more rolls. look at the highest frequency and its ratio for 20. Okay. So by looking at mine in general, let's see, I have 3, 4, 6, 5, 6. So that will be my highest frequency. Now keep in mind that if you use different compiler, you also get different result. And then after you look at the highest frequency, you can look at the lowest frequency value and note the ratio out of the 20 row. We only have 3 exercises today, so it's going to be a short night for everyone. So after you put down the highest, the lowest frequency, and the ratio, we wanted to compare between the 10 and the 20 rolls. Are there similarities and differences? Are the frequency the same or different? And then the last question for exercise 3 is what can you make as the general observation about RAN and SRAN? Okay. And we mentioned that all the way through the lab. Which one is pseudo-random? Which one looks like random, but it's not, right? SRAN, what does it use to make it randomized? And I know all programming language, C++, Python, Java, all have built-in random functions. So now you can see the difference between RAN and SRAN, well, for C++ at least. And then if you wanted to look at it closer, you can find some documentation for C++. You can go to C++ website and read up on, look at the template and see how that program is defined or written. For SRAN or RAN. Okay, questions? Okay, so before we head out and end the session, for next week, we're gonna work with algorithm, okay? So that means that we are gonna work with search and sort. And for my search and sort program, not doing anything intense like, so can the lowest frequency be 0? Yeah, if it doesn't show up, you can have it as 0. So if there's a number that didn't show up, right? So look at all the numbers between 1 through 6. If one that doesn't show up, then that would be 0. Yeah, so I want you to kind of take a look at how these programs are written, and possibly you can use it for your project, because not all projects you need to have random, but in the future, this is a good reference. Because I feel like many of my students, even the one that took advanced programming with me, they don't understand what random and what's not random. So, but for next week, we are going to do search and sort. I will not have, like, there's no, we're not going to write like a binary tree for search and sort, but at least we will look at a few methods on how to do search and sort. I've talked to some of my Java students who are now in this class, and via email when they were doing their project, right? Having the knowledge to know how to implement, linear or different type of search and sort is important, because in many cases you have to incorporate that mechanism. Of course, there are libraries, right? Built-in functions for search and sort. You guys seen that before. And I know for Python, definitely you can sort, and that, so it will already have some mechanism that you can use from the library itself, or you can write your own function to search and sort. So we will work on search and sort next week. In the lab, we will do that with C++. Okay. So if you have time this week, I will open the module next on Monday, but for it will be just be the next chapter after the chapter we just covered. So that will be chapter 10 in the old book. I think the new edition, it's like 11. But it's gonna go into algorithm and solving the problem. So we will look at different type of search and sort, like jump, chunk, stuff like that. And if you have taken data structure already, I'm sure you spent quite a bit of time on that. But we will look at like iterative approach. We'll look at recursive approach. So nothing too crazy with data structure like what you would see with CIS17C, because I want to make sure that the people who haven't gotten there yet would still be able to write the program, because it's you can have a simple search and sort program. So yeah, so I got a comment. Jacob said that it's interesting that srand uses the 1970 time and date reference. So there are a lot of things that we incorporate the clock, the time, and that would be the time that's counted since 1970 as computer time, right? I remember when I teach JavaScript, there were a few things that we also incorporated with the time functionality, and you would see that. So like whenever you use function that calls system time, right? That would be a UTC, but at the same time, it's referencing a point of time that they would clarify that this is the time that we're going to start counting as the system time in order to convert it so that way it would be our real time. So yeah, it's very interesting when you read into that and on how they incorporate some of that and show that as what we see today as a computer clock, okay, for the time. And then David said this lab raises some interesting question on exactly to generate the best possible random number. I didn't realize some algorithm use external data as seed, like thermal and yep. So, so as developer, I think you should start thinking about if you need to generate random numbers, right? How would you approach that? And it also depends on the criteria, right? What you're trying to solve for. But in the case simple things like card games, because I get questions from my students like, how do I generate this if I just wanted to simulate a blackjack game or a poker game? um, so you have to start thinking about what values you use to seed, and is that really going to simulate real world scenario, right? Because a lot of the time we write software to really represent what we see as human. um, so how can you solve it in a manner where it would be very realistic, and what kind of values you want to use. So that's something to kind of take away, because I think a lot of times people overlook these things and they just said that, oh, it's already in the library, I'll just use it. But how accurate is it? Um, and that's questionable. Okay. Okay. Well, do you have any questions for me? Okay. Is it okay to paste the roll button? Yeah, that's fine. Rashad, that's okay. Okay. And you're welcome. Make sure if you have time, just go through the chapter. The book is not heavy duty, so it gives you a lot of the example. I will release the material in the next week on Monday. Um, Congratulations to, I believe, Juan won the gift card. So we will have an upcoming quiz. Hold on one second. Let me check since I have y'all here. Okay. So I will post the video tonight. And then the travelers in Hawaii, you can work on that if you want some extra credit. I do extra credit periodically, so I give you opportunity to kind of make up things like if you miss something for attendance, or if you didn't do something, or you miss a few questions on the quiz, that kind of buffer it off. But extra credit is not meant to, like, for you to skip the project. If you do skip the project, you will take a hit on the grade. And I'm a fairly lenient grader. However, the project really tells me how you understand the material and how you can solve the problem using the concept we talked about. So um, we won't have another quiz until Unit 9, okay? So in Unit 8, I'm going to give you a quiz review. So we can safely say that when we go into our spring break, we don't have to worry too much about the quiz until we come back. I plan to release your project after you come back from spring break, right? Because this is week 6, you have 2 more weeks. Okay, so that means that like after week 8 is when we're going to see the project. Okay, because usually before I would release it about 10 or 11, but now I'm going to try to give you guys a little bit earlier time. I will post, we don't have a midterm. I don't do midterm. I do project and final and quizzes. So the quiz gives me periodic assessment on your performance along with your assignments and lab. And then the project tells me the overall understanding on how you would apply that with programming. And then the final is the overall understanding of the concept since day 1. So that would be adequate for me to assess your student learning outcome. So I don't give midterm. So you can, relax and, just get ready for the quiz in a few weeks when it comes, and then we'll talk about the project. Okay. I will post up a shared document where you will sign up for your group. I tried different technique and it hasn't been really working well, including Canvas group sign up. It was just so chaotic. And then, so I highly recommend that you find someone to work with if possible. If you absolutely decided that you wanted to do it on your own, that's fine. But keep in mind that I require different parts for the project and it can be tough, but I do not allow very large group. Okay. Maximum will be like about 3, 4 maybe, Okay, but I like it about 2 or 3 people per group. That kind of give you like a balance type of work. But when it becomes a large group, then someone is not going to do much of the work. So we'll touch back on the project down the line, and then we'll talk about what we need to turn in as a group and what we need to turn in individually. But yeah, so for we don't have much of homework to do except for to turn in your assignments and your lab for today. Work on the extra credit if you like, and if you include that in your assignments, you will get the grade for, if you get it correctly, you will get the grade for the travelers in Hawaii, the last case using matrices. Okay. And then we'll talk about algorithm next week. The following week, we'll move on to sequence and series, and then we'll do proof. Very light, nothing like calculus. So, um, and then, so pretty almost halfway done now. Okay. All right. Will the project be required detailed documentation like flowchart description? You know it. So I don't require I will require some, at least a summary of what your project is, what it is, what kind of concept that you apply from discrete, how you solve the problem. So I will have questions for you to answer in the document, and I will require either a flowchart or some pseudocode. So because I want you to make sure that you know how to plan and organize your programming project. Okay. So if you wanted to do flowchart, you can, or you can do pseudocode. Okay. Yep. So we'll talk more, and then I will show you how you can use GitHub if you want to use GitHub if you haven't used GitHub yet. And possibly if you wanted to put stuff on Google site, you can to keep up an e-portfolio for your career. All right, type your name into the chat, please. I'll stick around for a little bit for questions. If you have any questions, please let me know. And I will see you next week. Have a wonderful weekend. Thank you. Bye, Sarah. Thank you, Eric. Have a good one. Have a good night. Take care, Eric. Thank you.